All right, guys, so our first video here is just going to summarize some of the things that we know about friction. If you haven't learned about friction before, hopefully this will be simple enough that you'll be able to kind of understand some of the principles that we're talking about here. The first thing that we talked about in class is that only two things matter, right? The types of surfaces and the normal force between the two surfaces. Now, these two things mattered because of that idea of our first surface here and our second surface there, and just kind of those jagged edges, right? The jagged edges that we see there are then going to cause what we call friction, right? We don't see that, but it results in what we see as friction. Now, if the two objects are at rest, then there is no friction, right? There is no extra force there. That force comes into play when either those two objects are trying to slide or when they are sliding, right? That's the only two times that you're going to get friction to actually show up. Okay, now these two things, you'll notice that we talked about the type of surfaces here. So the type of surface is going to affect how much friction there is. Now that should kind of make sense, because if my surface is more jagged down here, then I expect to have much more friction. If my surface is smoother, then I don't expect to have as much catching and as much jaggedness going on, so there shouldn't be as much friction. So the types of the two surfaces is going to matter. Now, what we use to kind of quantify that is this mu, which is the coefficient of friction. That coefficient of friction is just a ratio that connects the frictional force to the normal force, or how hard those forces are pushing against each other, right? That's the second thing that we look at here, is the normal force between the surfaces. That's how hard those two surfaces are pushing up against each other. That should make sense, because the harder that they push against each other, the more likely it is that we're going to get caught up on those jagged edges, and the harder it is going to be for something either to start sliding or to slide once we get it started. All right, so that's what we're looking at here. The type of the surface, which correlates specifically to the coefficient of friction, and then the normal force between those two surfaces. That's what matters. That's the only thing that matters. All the other things that you might think of will affect one of those two. Pulling up will decrease the normal force. Pushing down a heavier mass will increase the normal force. Putting on a ramp, that will change the normal force, right? Everything that you might do to affect how much friction is there is going to affect one of these two things. Now, there's a lot of confusion usually about this coefficient of friction. This is just a number, right? You might, for example, get that the coefficient of friction equals 0.5, 0.5. It doesn't have any units, right? All it does is it connects in a way the force of friction to the normal force. It says how much of that normal force is going to kind of demonstrate itself or manifest itself as friction. This coefficient of friction depends on the type of surfaces, right? Wood on wood is going to have a specific coefficient of friction. Rubber on asphalt is going to have a specific coefficient of friction. So depending on what the two surfaces are that are trying to slide or that are moving, that's going to determine what the coefficient of friction is. And you're going to see that in some problems. So if you're still kind of iffy on that, don't worry. We'll see it show up a couple of times in problems. Now, the other thing that we talked about is that we actually have two different kinds of friction. All right, so static friction and kinetic friction. Again, what's important is the interaction between these two surfaces. In static friction, those two surfaces are not sliding, but they're trying to, right? If there was no friction, those two surfaces would be slipping and sliding along. But static friction means that they are not sliding, but trying to. All right, so a good example of this would be as you push on a box that's on the floor. The box will resist that motion because of the friction between the box and the floor. So it's not sliding yet, but it's trying to as I push on it. That's static friction. When the box is just sitting there and I'm not pushing on it, there is no static friction because it's not trying to move. All right. Another good example would be like when you walk, right? When you walk, if there was no friction, your feet would just slip along the ground. You wouldn't go anywhere. But because of friction, your feet kind of push back. They would slide, but friction actually pushes them forward. The feet and your ground don't slide, but they're trying to, right? If there was no friction, they would slide. So static friction there, the two surfaces are not sliding, but maybe they're trying to. A car, wheels on the ground would be the same thing, right? If there's no friction, the wheels of your car would just spin on the ground. They just slide along. But as you're driving along the road, they don't. At the point of contact, yes, the car is moving, but the interaction between the tire and the ground, it is not sliding, okay? Kinetic friction is when it is sliding. Now, this is important because kinetic friction will always be equal to the coefficient of kinetic friction times the normal force. Okay, so it doesn't matter what other forces are in play. It doesn't matter how long you do it. It doesn't matter how fast you're moving. The kinetic friction is going to depend only on the kinetic coefficient of friction and the normal force. All right? The kinetic friction is always going to have a specific value as your object is sliding along. It doesn't matter how fast it's moving because it's these surfaces and the interaction between those surfaces. Moving faster doesn't change those surfaces or their interaction. And so the only thing that matters is the normal force and the coefficient of friction. Now, sometimes students have a difficult time with the static friction because your static friction can have different values. Okay, now the maximum value, maybe this will be helpful. The maximum value is equal to the coefficient of static friction times the normal force, right? And you've actually, and this is, if you multiply those two numbers, then you get the maximum possible force of friction. If you go over that, then it's not going to be static anymore, right? If I push harder than the amount of static friction that is available, let's picture this. We've got a box on the ground, okay? The box is sitting there. There is some type of coefficient of static friction between the ground and my box based off of what they're made of, okay? There is a gravitational force and there is a normal force. That normal force is not changing here. That's going to be equal to the force of gravity, just upwards, right? So those two forces are equal. So the maximum amount of static friction that can be here is the static coefficient of friction times the normal force. Right now, the box is at rest, and so the static coefficient of friction is 0. If I start pushing, so I come over here, and I start, I got long arms, I start pushing the box in that direction. I push with a force of F. Now, if the box is not sliding, it's because the static friction is pushing back in the opposite direction with the same amount. Remember, this is Newton's first law. The object maintains its state of motion as long as those forces are balanced. So as long as the box is at rest, then the static friction will be equal to whatever force I'm applying on it. Right? Those two forces will be equal so that the object stays at rest. That static friction will increase as I push harder on it. Now, at some point, I'm going to, due to my buffness, I'm going to push so hard that I'm pushing harder than whatever the static force of friction is. If I push harder than what is available, because remember, there's only a certain amount available. It can only go up to the coefficient of friction times the normal force. If I push harder than that, then no longer will the box be at rest. It's now going to move forward. It's going to accelerate forward. Okay? And so that's why we usually say that the static force of friction is less than or equal to the static coefficient times the normal force. Because it can be 0, and it can be any other value based off of how much friction, how much force is being applied to it. The only difference is that at some point If I apply too much force, then if I get over this, then I'm over the amount of static friction that is available, and therefore it starts sliding. And at this point, a lot of you are saying, oh yeah, at this point, it now becomes kinetic friction, okay? And so that's why when you look in your formula packet, you'll see this, that the force of friction is less than or equal to the coefficient times the normal force, because it can be up to that level, but it can be anything less as well. We could even have zero friction if the object's not trying to slide. Okay, so hopefully that gives you a little bit of introduction. I'm going to introduce you to a couple of problems in the next couple of videos that hopefully will help you see how we will use this idea of the force of friction equals the coefficient times the normal force. All right, so come along with me in the next video and let's check it out.